Hello guys, it's Mr. Sakolo again. Today we're going to be working with, this is a grade 10 class. For the subject is information technology. Today we're going to be working with a nested if statement where we are going to be using an else. So the first thing that I am going to do, I am going to recap on our previous work that we did. Okay, let me just open my PowerPoint here so that it can be more clear. So here I've got a sample of a code for a nested if statement. And here I've got an algorithm. I want to use this algorithm to explain what is going to be happening here on this if statement. Okay, here we know that the if statement, we use it to test conditions if they are true or false. So if the condition is true, then we get the answer. If the condition is false, then we don't get the answer. So just like here, I've just made a simple, yesterday when we used, on the previous lesson, when we used if statement, we didn't have else. We were just using if. So now I want to show you when you are going to use the else. So maybe for the first one, always you're going to start like this. If this condition, iNum is less than or equals to A, you display the result. If the condition, or else, if the condition A is greater than iNum, then you display the result. Else, if the condition iNum and A is not equals to, iNum is not equals to A, then display the result. Let me just put a scenario here, just a simple scenario. Let's say A is time. The time you are supposed to be home at, maybe when you are supposed to be at home at 6. And then let's say here you came home before 6 because this is less than, or you came at 6. Then your parent result will be like, good, my kid is listening, he's coming, he or she is coming at home in time. But if you come after 6, if iNum will be 6, and then it's greater than A, then the time that you came with is it's late, it's later than 6, so your parent will be angry. So the result is that your parent is going to shout at you. Else you didn't come home at all. Then when you come in the morning, they just say, pick your clothes and go. So here you are testing this time. This is 6. Here you came at time, or you came before 6, or you came at 6. Then your parent will be happy. Good, that's good. But here, if it happens that there is another condition, you come at 7, obviously your parent should be happy. That will be the result. But if you don't come at all, I'm just using this not equal to sign to just make this scenario work. Then you didn't come at home at all. Then parent will be even more angry than when you came late. So when it comes here to this algorithm here, I made this algorithm just to display these results here. So here, what's going on here, we are going to input the time you came with. So if the time is less than 6 or is equals to 6, then you came early, the result should return true. Your parent is going to be happy. the first one. But if else, so here that is what is happening. This is the decision-making process. So whatever input you have put here will come here and be tested here. This is where the testing statement is going to happen for the first time. So when it happens for the first time, it finds out that you came early around 6, then it will be true. It will go this way, then we get to the answer quickly. But else, that did not happen. The results are going to be false. So when they are false, when the results are false, we still have another condition here. So when it is false, the results are going to come here. Here is the condition. You came after the time that you are supposed to come at. You came after 6. So what is going to happen here? So this condition will be true. So that is what we're testing on the second one. Okay, there was supposed to be a third one, but then I didn't do it. So here we are going to put it here to false. So if this statement is true, always the program will come this side and return it to be true. Else the condition is false, it will continue and come here. If there was another condition here, it was going to test that condition and go to that to the next possible answers that we have put to the program. So here, this is almost the same thing that is happening here between this code and this algorithm. This algorithm is just showing you clearly what is happening there when we put the else. When we put the else, we want this answer to be true. So if it is true, the program will come here and stop and show you the results. But if the answer is false, the program will continue and come here and test the else statement now. So now we've got else if this was not true. So we come here. If the second one is true, then we're going to get the results here. But if it was not true and we had other conditions that we need to test, then it was going to quickly come here and find the testing condition. If it is true, it will go this way. Okay, just a mistake. I clicked on the slide. It will go this way, and if it is false, it will go that way and continue. This can be continuous and continuous. So I just did this algorithm today, just this pseudocode and this algorithm, just to show you how does this statement operate. This is if this is true, first quickly go and return the answer. Else it is false, it continues to the next condition. If this condition is true, then you're going to get the answer, it will display the answer. Else the condition is false, it continues. If there was another condition, it was going to be just like that. Okay, so we're going to end it just here. So right now what we need to go to Delphi and do something and see if we understand what I am trying to explain here. So right now I'll just jump into Delphi. So here, I just wanted to do a small program. I made this thing so that we can be able to understand what I'm saying in a program. So here I was thinking about types of triangles. We've got a scalene, we've got an equilateral triangle, we've got an isosceles triangle. And all of these triangles have their properties. Remember a scalene triangle, in a scalene triangle, no side is equal to the other side. So I've put this so that we can refer to it when we do our program. No side is equal to another side. And then on an equilateral triangle, all the sides of an equilateral triangle are equal. And when it comes to an isosceles triangle, only two sides are equal. only two sides are equal. So here I've just made a scenario that this is a triangle is going to have three sides, right? So we're going to say we've got side A, side B, and side C. So here we want to test, when we put numbers here, the length of this side and the length of this side and the length of this side, if no sides are equal here on the length of the sides A, B, and C. So it means our triangle is going to be what? A scaling triangle, because no sides will be equal. And if we put all our sides here and they are all equal, maybe side A is equals to 6 centimeters, side B is equals to 6 centimeters, side C is also 6 centimeters, then it means our triangle here, it's an equilateral triangle. So, but if we put A and B are equal and C is different, then our triangle should be an isosceles triangle. So I made this, so we're going to print here. This is a rich edit text. I didn't change the name, so it just displays as a rich edit text one. So this is our button. So let me just rename the button because I have just put it here. Okay, let me just rename our button and name it decided triangle. Okay, what did I do? Come to my caption. Okay, decide the triangle. Okay, so our button here is where we're going to put the process to decide our triangle. And then here we've got edit 3, edit 2, edit 1. It's where we're going to be putting our measurements of our triangles, whether it is 6 centimeters, 7 centimeters, 10 centimeters. So I will double click on my button. Is there anything that I need to explain? So I have already said that if all these sides are equal, so we're going to be referring to this instruction that I have put here. So right now, let's jump into it. Okay, here I've declared variables A, B, C as integer types. So this is A, this is B, this is C. This is the length for A, the length for B, the length for C. And then what is going to happen right now, let me just double click here and go back to the code. Okay, I've just put this thing here, these comments here in purpose. Okay. So remember, the first thing that we need to do is to assign our variables with our edits, because that is where we're going to be putting our inputs here. So first thing, we're going to say A will be equals to, A is associated with edit 1. Let me double check before I do any mistakes. So here where we were supposed to put A, yes, it's edit 1. Where we're supposed to put B, yes, it's edit 2. And then we're supposed to put C, it's edit 3. Perfect. So right now, what we're going to do, let's assign our variables with the edits. So what I'm going to do now, I'm going to convert. Remember, we need to convert because right now we are working with integers. String to int. String to int. Yep. In brackets and close them. I like to open the bracket and close it at the same time and close the program, because these are the simple mistakes that we tend to do and then find out we get errors. I'm trying to avoid errors. So here we're going to say it's edit 1 dot text. Edit 1 dot text. Okay. Then we come here to B. B will be equals to 82, but even B as well, we must convert its string to int. Then open close. Int string to I've put I here instead of O. So here I will come here, edit 2 dot text. Okay, and then now we're going to come to C. C will be equals to string to float, string to int. I'm sorry, not to float, to int. Then open bracket and close them. Close this bracket. Okay, so here we're going to have edit 3 dot text. All right, now we have to look at our conditions. The first one, I will start with a scaling. A scaling has no side that is equal to another side. So what I am going to do here, I'm going to put my if statement. The first one, it will be if what is happening. Let's say if A, let's say not. Remember those logic operators that we once used? I think they will be useful here. When we started with the if statement, we used O, we use, remember there was equal to, let me start with the operators only. There was equal, there was not equal to, there was less than and greater than, or greater than, or equal to, or less than or equal to. Those are the logical operators that are relevant now. And also we had, those are the operators. So we had logical operators, we had not, we had and we had or. So all of them we're going to use now. So remember when we say not, so it means it should be the opposite of what we're saying. Why is my computer doing like this? Okay, this is this button. It is busy delaying me here. So we're going to say not A is equals to B. So B and A are not equal. Then we're going to use another logical operator here, and. So when we put and, remember and, both the conditions must meet the requirements, the things that we want. Not A is equals to B. Let's use not again. And not, let's say not A is equals to B. And not A is equals to C. And not A is equals to C. Yep. So none of these are equal. And then let me say what again. Let's say or. Let's use or now because it's still the same. Or B, let me say B or not. Let's say or B not. Let's use this one now. Not. No, let's not use or here. Or we okay, can use it. We will see what it brings to us. Or B is not equals to C. So none of these are equal to each other. Not A is equal to B, and not A is equals to C, or B and also B is not equal to C. Then what should happen? We are going to print the results. There is a rich edit text one. No, it's a rich edit one. Dot, remember when we use an edit, we're going to say dot lines dot add. All right. So what will be our results here? So our results here will be, let me see. This is a scalene. This is a scalene. Okay. Okay, here I'm going to close it because I just want to test here if there is anything wrong here. All right. So I will run my program and test this first line. If there are no errors so far, all right, it seems as if so far so good. So what is this now? Oh, I don't want this to happen. Why is this thing happening? Okay. My program is still running, but it is running slow. What is happening with my mouse? Okay, my program is still running. Why is this thing happening? Okay, here is my program now. My mouse is all over the place. Why? Okay, I think my mouse has a problem. Okay, so I will use this one. Let me minimize this. All right, so everything is under control here. What's going on? Okay. Where is it? My phone. Okay, let me remove this. All right, let me see, where is my, all right, there we go. Let's say we've got 5 here, we've got 8 here, and then we've got 9 here. Let's see what is going to happen. All right, this is a scalene because none of the sides are equal. So right now we know we got it right. So now we need the else part. Remember, when you're going to put an else, you have to remove, you don't have to close the line here, you have to remove this. I put it there because I was just testing it with one line. So here you come to the next line. Let's say if else if. Let me open some space here so that it can be a bit clear. Yeah. So else if what? So else if now we are looking for an equilateral triangle, and we know that in an equilateral triangle, all the sides need to be equal. So I'm going to put this in brackets. So I will say A will be equal to B, and let me put another bracket here. Remember, when we use and, both conditions should be true in order for us to return true, to return the answer to be true. So right now I will say, even if I can say A is equals to C. So automatically now what is happening, if A is equals to B and A is equals to C, so it means that C is already equals to B, because that is what we are saying here. So now we can print out our result. It means that all of our sides are equal. Even if there I said B is equals to C, still the same thing. And then what should happen? We're going to need this rich edit text, rich edit 1 dot lines dot add. Okay, so we're going to say, open here. So here we're going to say this is a, this is an equilateral. How do you write equilateral? Doesn't matter whether the spelling is wrong, you understand what I mean? Okay, let's close this here and test. So where is it going to put us? So if all these sides are equal, then we should get this answer. Okay, let me test this one. Okay, the program is running. Just a minute. All right, there we go. Say A is 6 centimeters. All the sides of our triangles are 6 centimeters. So let's see if we get the right result. Boom, there we go. So right now we're going to use an else. So remember too, this should not be here. So I will put another else if what? So we need two sides to be equal here. Say if A and B are equal, then we're cool. And then and if B is equals to C or A is equals to C, therefore none of them is equals to C. All right, let's get into it. So we're going to say close bracket A is equals to A and what? Either A or B is not equals to C, definitely the other one will not be equal to C too. So we're going to say brackets and then A is not, let's just use this sign, A is not equals to C. Then what do we need to do? We need to print here on our reach edit test. Let me take this a bit back. Reach edit to one dot lines dot add. Then what are we printing here? It's an isosceles triangle. This is an isosceles triangle. And then we close our program. Close here. Okay, in else, if else, you close on the last line. You see here, I didn't close. Even here, see this one is not closed. Even this one is not closed. But here, because we're on the on the last one, then I'm going to use my semicolons and close. Okay, and then run my program. But I suspect something here. Okay. Remember, when two sides are equal, they should. Okay, let me say here, A is equals to 3, and then B is 3 as well, and then the last one is 9. Then we say go. This is a scaling. Okay. Why? So I'm suspecting O, because A here should be equals to B, and then A. Okay, let's I want us to use this. Let's use this. Not equals to, and then we should use this not here, because this thing tend to prove us wrong, but then we're going to prove it wrong as well. And here, another mistake that is here is when we use or. Remember, when we use or, not all the conditions should be true. I think that's the other problem. That's the other problem. Okay, but let's run it and see. So we're going to have to fix this problem here. I guess you see it. When we say or here, which means the other things are not true. So we're going to remove all and then test it. All right. Okay. So right now, let's say go and test it. Remember, this is a testing statement. We're going to test it, and then until we get the results that we want. But I think now everything is good. So right now, let's test it like this. The first triangle, I want it to be a scalene like here. So I'll make everything to be different. Let's say here it's 77, here it's 45 centimeter, and here it's 43 centimeter. Then we test it. Okay, well, cool. This is a scalene. Okay, let me remove this. Remove. Okay. All right, now let's say we want an equilateral. We want this to be 44, and this one should be 44, and this one should be 44 as well. Then when we run it, we should get an equilateral because all these three sides must be equal. Okay, it's an equilateral. Okay, it seems as if we're good. Okay, and then now when we come here, let's say this is going to be 55, and this is going to be 55 as well, and this is going to be 90. Then let's see, what do we get? We should get an isosceles. Boom. All right, it means now all our tests are correct. So guys, this is how the if statement with an else operate. So if we wanted to put another condition, I don't know what it would be because we have only three conditions here, and then we have only three things. Okay. So here, this is just a simple if else statement. Or here we can just say else print results, or we can just put a last else print results if none of the conditions are true. Yeah, we can do it, but then this is just a basic. So let me just go back here. So you see this thing is also going with the thing that the algorithms we're doing there. So here on this algorithm, you are putting all the possible values, and then they run here in this process, this button. After running here, this one, if it doesn't get true, it jump to the next one and process it and check if it will return a true answer. And then if this one doesn't get true, it jump it and go to this one. So here, maybe even if we can just say else the condition, or maybe we can say or maybe we can say if we were to just finish it and then else show message. So right now, if all these conditions are false, this is what is going to happen. Else show message, show message, what is going on now? Else show message, none of this is true. So if none of these conditions apply here, then we are going to get this message. So here we don't have a condition here because this is the last one to be tested. So if this one doesn't test true, then its false is going to come to this line. So none of these conditions will be true. So that is how it goes. So it won't run. I was trying to not put a number here. So, okay, let me just leave it like this. Okay, so guys, I hope this was understandable. Here we put here our inputs here. We don't get the answer to be true. We jump to the next line on else because this first one was false. It prosecute here. It jump to this to the next line else because this one was false, and then here we get the final answer. Okay, so let me just do a quick recap here on our algorithm. So here is the algorithm that we were using. Come here, true, take you straight to the answer. False, go to another question, to another condition. That is how it operates. So guys, thank you so much for being here and tuning in. You know, you guys are the best. So if you have any question, you can email me at tobisisacolo@gmail.com. Okay, bye guys.